Hello everybody, today I want to talk about some key parts of a quadratic function. A quadratic function is a function where one that you are familiar with is the form of ax squared plus bx plus c. And in this part of the chapter, we're going to extend that and put it as y equals. Sometimes that y is represented as f of x. So you can also see this as f of x equals ax squared plus bx plus c. You can think of the word function as equation if that is more familiar to you, but we will be using the word function throughout this chapter. All right, let's begin with the way that the graph looks. The graph of a quadratic is a curved shape, okay, that we call a parabola. And again, that's pronounced parabola. A parabola is, if you were to think of its shape, is a U-shaped graph. Okay, there are two ways that a parabola can look. A parabola can face up. A parabola can face down. There are ways that we can tell from an equation whether a parabola is going to face up or down, and we will be talking about that as the unit goes on. So let's talk about some key parts of this quadratic graph known as the parabola. One of the key parts of a quadratic graph is what we call the vertex. A vertex is the center or middle point of the graph. Remember that a point on a graph is always written as the ordered pair x, y. So we can think of the vertex as either the highest or the lowest point on the graph or of the graph. Often instead of highest or lowest, they like to use the term maximum and minimum. Okay? So if you're looking at a picture of a parabola, if the parabola faces down, your vertex is going to be that center, most highest maximum point, right there. If your parabola faces up like this, your vertex is going to be the lowest or the minimum point of the graph. Okay? A vertex is something that whenever you graph a parabola, you must have it as part of your graph. So this must be part of your graph. Okay? All right, let's move on to the next key part of the graph. The next key part of the graph is what we call the axis of symmetry. So the axis of symmetry is a vertical line that goes through the vertex And often on a graph, it's represented using a dashed line. Okay, the axis of symmetry, if we're looking at a parabola and you have a vertex, it'll look something like this. Think of the axis of symmetry sort of like a mirror. If you were to fold your parabola in half, where the axis of symmetry was your fold, each side of the parabola would line up with each other perfectly. It cuts the parabola into two symmetric sides, meaning that a point over here will be the same distance away from a point over here, this is something that we will definitely talk more about. Now, since the axis of symmetry is a vertical line graphs are always written as an equation, where it's x equals some number value. Okay? Since it is a line, when we represent the axis of symmetry, we represent it as an equation. So this is what an axis of symmetry name will look like. This value here, you will see, ends up always being the x value of this number here, always ends up being the x value of the vertex. Okay, so, and as we go through this unit, we will talk more and more about these things, so you will become more and more familiar with them. For right now, this is just vocabulary. So let's talk about other key parts of a quadratic graph, and those are what we call the intercepts. In a quadratic graph, you can have both x-intercepts and you can have a y-intercept. Okay, remember from linear equations what these two things are. For an x-intercept, it can have 0, 1, or 2 x-intercepts. Remember, an x-intercept is where the graph crosses or touches or intersects the x-axis. Any point on the x-axis will always have the form of some x value, comma, 0. For a x-intercept, the y value is always 0. Now for a y-intercept, a quadratic, we'll have one y-intercept. It cannot have two because there's no way for it to loop back around and hit the y-axis again. For a quadratic function, remember that a y-intercept is where the graph crosses, touches, what intersects. There's lots of different words you can use. It's where the graph crosses the y-axis. Okay, so for a quadratic, or any type of function, a point that is on the y-axis is always going to be 0, comma, y, where the x value is always 0. Now, to just relate that to the form that I wrote up above, the y equals ax squared plus bx plus c, imagine if you plugged in 0 or evaluated the function when x is 0. Well, 0 times anything is going to cancel that out. 0 times anything here is going to cancel that out. So whenever it's in this form, you can see that it's going to be fairly simple to see, no pun intended, that the y-intercept is going to be this value here whenever you evaluate the function when x equals 0. So later you will see the connection that the y-intercept can also be thought of as the point 0, c, where c is that constant value in standard form. Okay, so let's take a look at all of this stuff together here. So in this picture, everything I've talked about is represented here. So looking at this picture here, the shape here, as you can see, is a parabola. So this is a parabola graph. Okay, so that means that the points on this are represented from a quadratic function. Okay, so in this quadratic function graph, one of the important points that we see down here at the very bottom, this is what we would call the vertex. The vertex of this graph is the point 1, 4. Okay, the line or the dashed line, as you can see going down the middle here, this is what we call the axis of symmetry. Remember, the axis of symmetry is a line. It's a vertical line. Any vertical line is represented by an equation, x equals. And this is going through where x equals 1. So the equation for the axis of symmetry is going to be x equals 1. These points here that are on the x-axis, these are what we call our x-intercepts. It is possible for you to have more than one x-intercept, and you can see that these are these points here in red. In naming those points, this point over here on the left is -1, 0. This one over here on the right is the point 3, 0. And then last, this point down here on the y-axis is what we call the y-intercept. There is one of those, and it is going to be the point 0, -3. So this is a really nice summary of all the key parts of a quadratic functions graph. So I hope you enjoyed this video, and good luck with your practice.